Ya Farhah, kena isi untuk hari ni apa? Hari Rabu, waktu lain-lain. Tapi jangan lupa isi lah. So semua orang sila isi attendance hari Rabu, waktu lain-lain. Okay, so berapa orang dah? 13. Alright, nampak macam berhenti ni. Tapi jangan lupa isi lah. Macam berhenti sikit. Okay kot, tak apa. Right. Berapa orang? 13. Okay, tak apalah, kita go slow-slow lah. Nanti diorang akan masuk ataupun diorang akan tengok yang lama kan. So okay lah. Okay, so now let us start then. Okay, so last time I stopped at example 2. So that means for today, let us proceed straight away with example 3 and example 4, and then I'll proceed with the partial fraction. So our main focus for today is partial fraction actually, but let me finish example 3 and example 4 first, and then we're gonna do partial fraction. Okay, so example 3. The polynomial px is given by px equal to x cubed plus 3x squared plus x minus 1. Show that x plus 1 is a factor of px. So we got to show x plus 1 is a factor of px. Hence determine all the roots of px. Okay, so since we want to show that x plus 1 is a factor of px, we should use the factor theorem where if we substitute p of negative 1, we are supposed to show that we are definitely going to get 0. Okay, so let me do that. To substitute x with negative 1. So we are going to get negative 1 cubed plus 3 times negative 1 square plus negative 1 minus with 1. And then of course you can actually simplify them. Therefore, this is actually equal to 0. Since p of negative 1 is equal to 0, we can easily say that x plus 1 is a factor of px. So that is how we show that x plus 1 is a factor of px. So we use the factor theorem, substitute the value of the a, and then we show that when we substitute the value of the a, the answer on the right hand side will give us 0. Okay, so now let us determine all the roots. Okay, so we already have one of the root, which is x plus 1. One of the factors, so we already have one of the factor, which is x plus 1. So let us use the long division to find the other factors. Okay, so x cubed plus 3x squared plus x minus 1 divide with x plus 1. So let us think a little bit. X times with what in order to get x cubed? So x needs to be multiplied with x squared. So multiply with x squared. So x multiply with x squared, we are going to get x cubed. 1 times with x squared, we are going to get x squared. And then of course, put a bracket over here. We're going to minus them. So x cubed minus x cubed, it will become 0. 3x squared minus x squared, therefore it will become 2x squared. And then you simply bring down the x. So we got 2x squared plus x. Okay, so now we got to think x times with what in order to get 2x squared. So obviously x multiply with 2x. So write down 2x. Okay, so x times with 2x, we are going to get 2x squared. 1 times with 2x, we are going to get positive 2x. Then like usual, put a bracket with a minus. Okay, so of course we should minus them. So 2x squared minus 2x squared, 0. X minus 2x, so it will become negative x. And then simply bring down negative 1. Okay, so since x is over here, this is negative x. So x should times with negative 1 in order to get negative x. So times them with -1. So x times -1 is -x. 1 times with -1 will become -1. So we are going to get -x, -1. And then of course we should minus them. And then as you can see, when we minus, it should become 0. Okay, so that means if px is equal to 0, that means one of the factor is x plus 1. Another factor is our quotient before this. So this is the quotient that we get. So x square plus with 2x minus 1 equal to 0. So bila kita factorize px tu kita dapat dua benda lah. One is the divisor and then another one is the quotient equal to 0. Okay, so since we want to find out what is the roots, so the first one, x plus 1 is equal to 0, which means that x must be equal to -1. Another one is x squared plus 2x minus 1 equal to 0. So check first, can we factorize them using the cross method yang cross tu kan? If let's say you cannot cross them, and you cannot factorize them, that means we have to use the formula. So kalau kita boleh factorize, kita factorize completely macam biasa. If let's say we cannot factorize them completely, therefore we got to use the formula. So the formula is negative b. So x equal to negative b plus minus square root of b square minus 4ac divided with 2a. So we are going to use this formula when we cannot factorize them completely like usual. Yang method yang cross tu kan. So tak boleh, kita akan pakai formula. Okay, so substitute all the a, all the b, all the c. And then you're going to get that x is equal to -2 plus minus square root of 8 plus over 2. And then square root of 8, this one can actually be simplified because square root of 8 is actually square root of 4 times with 2. So this is square root of 4, square root of 2, and square root of 4 is actually 2. So we got 2 set 2 or 2 square root of 2. Okay, so what do we have is -2 plus minus 2 square root of 2 over 2, and then of course you can actually divide them by 2 ataupun kita kata factorize pun boleh juga lah. Factorize the 2 outside, so -1 plus minus set 2 over 2, and when you cancel out the 2, you will be left with -1 plus minus set 2. So that means the roots are x equal to -1, and another one is x equal to -1 plus minus square root of 2. Okay, so this one will give you two value actually, -1 plus set 2, and another one is -1 minus set 2. Okay, so I'm done with example 3. So let us proceed with example 4. Okay, so before we start with example 4, note that when attempting to factorize a polynomial of degree 4, it is necessary to find two linear factors using the factor theorem. So before this, if let's say we are having some cubic function, I ask you to use try and error once. But if let's say we have a polynomial of degree 4, that means you have to use the try and error twice. You should at least find out two linear factors first before you calculate them. Okay, so that is what it means over there. So let me proceed with example 4. Determine all the roots of x to the power of 4 plus x cubed minus 7x squared minus x plus 6 equal to 0 if x minus 1 and x plus 1 are the factors of px. Okay, so you are given two factors. So you are given x minus 1 and x plus 1. So that means we already know two of the factors. Okay, so let me write them down. Okay, so px is equal to x minus 1, x plus 1 together with another quadratic function. Why quadratic function? Basically these two, if you times them, you are going to get a quadratic. So in order to get x to the power of 4, the other factor must be a quadratic as well. So that when we times them, we are going to get x to the power of 4. So x squared times with x squared, only then we can get x to the power of 4. So that is why this one should be a quadratic. So again, why? This is a quadratic. So this is x minus 1, this is x plus 1. If you expand them, you are going to get x squared minus 1. So that means x squared minus 1 need to times with another x squared before we can get x to the power of 4, because the question said that the px should be x to the power of 4. So that is how I know I must have a quadratic function over here. But I didn't know what is the value for the a, b, and c. So I'll just leave them as ax squared plus bx plus with c. Okay, so now let us compare the left hand side and right hand side. So write down your px. Px is x to the power of 4 plus x cubed minus 7x squared minus x plus 6 equal to ax to the power of 4. So we expand this one. Ax to the power of 4 plus bx cubed plus with c minus ax squared minus with bx minus with c. Okay, so what do we do next is that we need to know what is the value of A, B, and C. So the easiest one is that we are going to use comparing coefficient. Why comparing coefficient? Because basically this is A, x to the power of 4, and this is x to the power of 4. So if we compare the left hand side and right hand side, compare the coefficient, we can directly see that the value of A need to be 1. And then if you compare the constant, you should be able to see this is positive 6, this is negative 6. So that negative c, sorry. So positive 6, negative 6, negative c, aduh pening tu. Negative c equal to 6. So that means you can easily calculate what is the value of c. And the same thing will happen to b as well. So this is negative x, this is negative bx, and again you can easily see what is the value of b. So for me, I prefer to use comparing coefficient. Okay, so by using the comparing coefficient, we can easily see that a should be equal to 1, b must be equal to 1, and c must be equal to negative 6. So by comparing coefficient, those are what we get. And then what happened is that based on your px, you are going to get x minus 1, x plus 1. So over here, this is ax squared plus with bx plus with c. So you simply substitute what is the value of a, the value of b, the value of c. So what do we have is x squared plus x minus with 6. So check first for this one. Can you factorize them completely or not? Obviously, you already have the next line. So you already know that you can easily factorize them. But do make sure to check them first. So kalau dapat benda yang macam ni, kuadratik macam ni, check dulu boleh factorize ke tak. Okay, so we can actually factorize them to become x plus 3 and x minus 2. So x minus 1, x plus 1, x plus 3, x minus 2. Okay, so now, if px is equal to 0, then everything is equal to 0. Therefore, the roots are x equal to negative 3, x equal to 1, x equal to negative 1, or x equal to 2. So we're going to list down all the roots. Okay, so those are the roots. I think that's it for example 4. So yang ini je, example 4. Okay, so now let us start with the partial fraction. Okay, so introduction to partial fraction. Basically, you got to learn partial fraction. Besides using it in semester 1, we are going to use them further in the second semester. So when we are solving some integration question, we need to use partial fraction. So that means to make sure you really know how to do partial fraction. Okay, so introduction, fractions. For example, 3 over x, 2 over x minus 2. So those are known as the fraction. Okay, so if let's say we have 3 over x minus 2 over x minus 2, so if let's say we cross multiply and we are having the same denominator on the right hand side, this is what we call as a single fraction. Okay, so conversely, we can actually reverse the process. So we can actually start from the single fraction and separate them into two different fractions. So these are known as the partial fractions. So in general, partial fraction is a collection of fraction whose sum equal to the given fraction. So biasanya kita samakan membawah kan, tapi kali ni kita nak tukar dia kepada dua fraction. Okay, so a little bit of definition. Okay, so a fraction can be expressed or decomposed as the sum of two or more separate proper fraction. So this is known as partial fractions. So for example, if let's say we have px over qx, so we actually want to separate them into a few fractions. So a over b, c over d, e over f. So those are known as the partial fraction. So we start with a single fraction on the left hand side, and then we want to separate them into a sum of two or more fraction. Okay, so let us talk about the types of fraction. Okay, so basically we have two types of fraction. We can have a proper fraction, we can have an improper fraction. So for proper fraction, the degree of the numerator should be less than the degree of your denominator. Okay, so if you have a fraction, your above one, this is what we call as the numerator, and the below one, this is your denominator. So what it said over here is that the degree of your numerator should be less than the degree of your denominator. So atas kena rendah daripada bawah. Okay, so numerator should be less than denominator. So that is what it means by proper fraction. Improper is the opposite of proper fraction. So for improper fraction, the degree of the numerator is greater than or equal to the degree of the denominator. Oh, yang ni tak nampak Sekejap Let me write them down again. So this one is n less than d. So this one, you should either have n greater than d or n greater than or equal to d. Okay, so either n greater than d or n equal to d. So either the numerator, the degree of the numerator is equal to your denominator, or the degree of the numerator should be greater than your denominator. Okay, so as you can see over here, this is the degree for this is x to the power of 4. The degree of this is x cubed. So the degree for your numerator is higher than your denominator. So this is called improper. For this one, this is x cubed. This is also x cubed. So the degree for your numerator is equal to the degree of your denominator. So sama dengan. So that means this is improper as well. Okay, so I forgot for this one. So let us check this one. So this is x squared, this is x cubed. So the degree for your numerator is less than your denominator. So this is a proper fraction as well. So this is x squared, this is x cubed. So this is also a proper fraction. So this is nothing without the x. This is something without the x. So this is actually x to the power of 0. So again, 0 is less than x to the power of 1. So this is also a proper fraction. Okay, so why do we need to learn about proper and improper fraction? So basically the way we solve them is slightly different for proper and improper fraction. So we only do partial fraction when we are having something with a proper fraction. If you have improper fraction, you got to do long division first. We need to change it into proper fraction before we can do partial fraction. Okay, so nampak ni macam pening sikit lah, tapi tak apalah. Okay, so type of fraction, we have two types like what I said previously, proper, improper. So basically, if we have improper fraction, you got to do long division first. Why? Because we want to change it into proper. Only if we have proper fraction, then we can do partial fraction. So kalau nak buat partial fraction, it must be in, dia mesti kena proper dulu. Oh payah nak sebut. Proper fraction. Okay, so in fraction, you need to refer to your denominator. So always check your denominator. Is it a linear factor or is it a quadratic factor? If it is a linear factor, is it a distinct linear or is it a repeated linear? Distinct linear, that means you have different linear function. For example, x plus 1. So ini distinct lah. Dua linear yang berbeza. Or perhaps x minus 1 together with x plus 1. So those are distinct. We have two different linear factor. Repeated linear, that means we have the same linear function. So perhaps something like x squared or x minus 1 square. So those are repeated linear. Or if you look at your denominator, you might have a quadratic factor. So for your quadratic factor, you should check first, can you factorize them or can't you factorize them? If you can factorize them, then it will become a linear factor. Then you can easily check, is it a distinct or repeated linear? If it is a quadratic that cannot be factorized, then we're going to leave them as a quadratic that cannot be factorized. Okay, so now for proper fraction, how to do the partial fraction? Basically, if we have a distinct linear factor, then we are going to use some constant up here. So if let's say we have x minus 1, x plus 1, then it will become a constant over x plus 1, a constant over x minus 1, satu lagi. Sekejap. X minus 1. Okay, so quadratic factor, for example, x minus 2 over x squared plus x plus b. So if you have a quadratic, you should check first, can you factorize them or not? So if you cannot factorize them, then this one, it will become bx plus c. So x is a linear, so that is why we have a constant a. But x squared plus x plus c, this is a quadratic that cannot be factorized. That cannot be factorized. Let me add that for you. So that is why you have bx plus c. And then for repeated linear, for example, 1 over x minus 1 square, what do we have is a constant a over x minus 1 plus with another constant over x minus 1 square. Another one, x plus 1 over x minus 1 square. So this is a linear. This is a repeated linear. So what do we have is a over x first. So take the first one, a over x. And then this is for the repeated linear. So b over x minus 1, c over x minus 1 square. Tinggi sangat ke? Okay, so I think let us start with some of the example first. So this is the first case when we are having denominator with a distinct linear factors. Okay, so never mind, let me skip this. Okay, so let's say if you have x plus 5 over x minus 4, x plus 6, so those two are distinct linear factor. So when we separate them, one of them will be something over x minus 4 plus something over x plus 6. So this something, since this is a linear, we should write down a constant. So a over x minus 4 plus with b over x plus 6. So our job is to actually calculate what is the value of a and b. Second one, we got 7x minus 4 over x plus 3, x minus 5. Again, this is linear, this is linear. Okay, so separate them into two fractions. So something over x plus 3, something over x minus 5. But both of them are actually linear. So we can actually put a constant. So a over x plus 3, b over x minus 5. And of course, again, our job is to calculate what is the value of a and b. Okay, so now let us go to the example. Express 2x minus 3 over x plus 1, 3x plus 2 in partial fractions. So do check your denominator. What do you have in your denominator? Obviously, this is type 1. So they're going to give you some distinct linear. So this is linear. This is also linear. So we are going to get something over x plus 1. So something over x plus 1. Something over 3x plus 2 plus. And then since this is a linear, we are definitely going to get a constant up. So A plus, so this is again a linear. So this is B. And then we're going to write them in one line. Okay, so write each partial fraction with one of the linear factor of its denominator. So 2x minus 3 over x plus 1, 3x plus 2, it will become A over x plus 1 plus B over 3x plus 2. So that is your first step. Pastikan masa kita buka tu, kita buka dengan betul lah. Okay, next. Right, so now we need to add the partial fraction by putting them over a common denominator. Okay, so what I normally do is that I refer to my denominator and I refer to the denominator on the left hand side. So for example, I have a over x plus 1. So I take this denominator, so x plus 1, multiply with 3x plus 2, and then I divide with the denominator for a, which is x plus 1, and then I can see that these two can be cancelled out, so I'm left with 3x plus 2. So a need to times with 3x plus 2. Meanwhile, for the b, so we have x plus 1, 3x plus 2, over. So for the b, the denominator is 3x plus 2. So we are going to divide with 3x plus 2. So cancel out. You will be left with x plus 1. So that is how we know what should be times with a, what should be times with b. Okay, so that is the second step. Now, the third step. Okay, so since the denominator on both sides are equal, it follows that the two numerator must be equivalent to each other. So since we have the same denominator, we can easily compare our numerator. So comparing the numerator, we are going to get 2x minus 3 equal to a, 3x plus 2 plus with b, x plus 1. So now we got to solve to calculate what is the value of A and B. So there are two methods to solve this. You can either use substitution or you can use comparing coefficient, either one. By substitution, that means you can easily substitute any value of x that you want, but normally for me, I prefer to substitute the zeros of the denominator. So for example, the zeros of the denominator is negative 1 and negative 2 over 3. So I prefer to substitute with negative 1 and negative 2 over 3. But of course, you can actually substitute any number. Tapi kalau kita tak ganti dengan zeros, biasanya dia akan dapat term A dengan B lah. So nanti kita kena solve simultaneous equation. If you don't want to solve simultaneous equation, it will be easier if you substitute with the zeros. Bukan zero yang kosong tu tau. Zeros yang kita belajar sebelum ni. Kan kita ada root factor dengan zeros kan. So zeros of your denominator. In this case, your denominator is x plus 1 and 3x plus 2. So that means the zeros are negative 1 and negative 2 over 3. So for me, I prefer to substitute with the zeros. So that is the first step. The second step is by comparing the coefficient of the corresponding terms. So that means you expand them first and then you compare x squared on the left hand side, x squared on the right hand side, x on the left, x on the right, terms with a constant on the constant term on the left hand side and the constant term on the right hand side. So kena expand dulu and then kita compare bagi dia sama. So there are two methods. You can choose either one. Okay, so the first one, I'm using substitution first. And x equal to negative 1. So I simply substitute with x equal to negative 1. Okay, so this is the reason why I ask you to substitute with the zeros. If you substitute with the correct zeros, your factor will be equal to 0. So for example, over here, -1 plus 1, so this one will become 0. So when you times them with b, this is automatically 0. So we are no longer having anything with 0, so we can easily calculate what is the value of a. So a will be equal to 5. Another 0, or you can actually choose any numbers actually, up to you. So in this case, they choose x equal to 0. So you simply substitute x equal to 0. And then you can easily see that the value of b is equal to -13. So once you know the value of a, you should substitute that a is equal to 5 over here before you can solve to find out what is the value of b. So nak ganti zeros boleh, atau nak ganti apa-apa nilai pun boleh jugalah. Okay, so therefore 2x minus 3 over x plus 1, 3x plus 2 is simply 5 over x plus 1 minus 13 over 3x plus 2. Okay ke so far? Okay. Tak okay. Cik tulis sikit. Nak tengok hidup tak budak-budak ni. Bukan hidup tak apa. Hai, Miss kenal saya tak? Rasa macam budak last sesi. Rasanya lah. Asal you pula yang tengok live ni? Macam dah habis je belajar. Hidup. Tak lah, macam kalau tertidur tu untuk saya kata kurang hidup lah kalau tertidur tu. Tak macam mana, kira macam-macam lah teori. Hai, so apa cerita? Okey ke nak buat partial fraction ni? Okey, ni baru method 1 tau. Substitution, we have another one, comparing coefficient. Sekejap, loading sekejap otak ni. Pening sikit, hihi. Dia awal-awal dia pening sikit sebab dia banyak huruf kan, banyak X. Tapi dia lama-lama dia akan okay sikit lah. With practice, I'm sure you can do it. Okay, Ikram, bye. Okay, tak apa. Saya ajar lagi satu method. And then, saya bagi masa lah untuk awak buat yang example lagi satu. Okay, so now, the second method. So just now we learned how to use substitution. Another method is by using comparing coefficient. So you expand them. Once you expand, you collect like term. So collect like term, kumpul term yang sama. So for example, this is 3ax. So we got x over here. This is bx. So we got x over here. So collect like term. So we are going to get 3a plus bx plus 2a plus with b. And then you use comparing coefficient, compare left hand side and right hand side. Then you can easily see that 3a plus b must be equal to 2. So kalau kita compare term with x, so this is 2x, this is 3a plus bx. So that is how we come out with 3a plus b is equal to 2. So that one will become the first equation. And then compare for the constant. So you got 2a plus b is equal to -3. Again, solve them simultaneously. Then you are going to get a equal to 5, b is equal to -13. And again, your partial fraction will be 2x minus 3 over x plus 1, 3x plus 2 equal to 5 over x plus 1 minus 13 over 3x plus 2. Okay, so now let us go to the next example. I'll give you some hint and I'll give you some time to do it. Okay, so example 6. Express 5x plus 1 over x plus 1 to x minus 1 in partial fractions. Okay, so check your denominator first. What kind of factor do you have in your denominator? So tengok bahagian bawah, dekat bawah tu. Do we have a quadratic or do we have a linear? Obviously, you have linear and all of them are distinct. Dia linear dan dia adalah linear yang berbeza sebab kita tak nampak benda yang ada kuasa dua. So distinct linear. Okay, so one fraction will be for the first linear factor. So the first one is x, so something over x plus something over x plus 1 plus something over 2x minus 1. And then since everything is simply a linear, so we are going to use a constant. So this is A, B, C. So now our job is to calculate what is the value of A, what is the value of B, what is the value of C. Okay, so kita pecahkan dulu. So 5x plus 1 over x plus 1, 2x minus 1 equal to A over x, B over x plus 1, C over 2x minus 1. And then you need to have a common denominator. So samakan pembawah, cari and then compare awak punya numerator and then solve lah. Either nak guna substitution ataupun comparing coefficient. Okay, so I'll give you how many minutes should I give you? 5 minutes? Will that be enough? So I'll give you around 5 minutes for you to find out what is the value of A, B and C. If let's say you couldn't finish them within 5 minutes, let us see where you get stuck and then how to solve that one. So I'll give you 5 minutes starting from now. Azri tu macam budak SEM lepas juga je, bukan ke? Macam budak-budak SEM lepas saya suka datang lah. Sabar je lah. Suka benar dia orang meninggal. Mesti korang pelik dia tengok apa. Macam sukar. Enggak sukar dong. Senang aja. Okay, so kalau boleh buat, kalau rasa macam tak boleh buat, so dengar sikit lah hint daripada saya. Okay, so let's say you have A over X, right? So you want to have a common denominator. So for me, it is a good practice to compare your denominator with the denominator on the left hand side. So biasanya kalau untuk saya akan cuba bahagi apa yang balance, benda tu saya akan darab dengan A untuk samakan pembawah lah. Okay, so what did I do is that I take on the left hand side, I have x plus 1 and then 2x minus 1. So I simply divide. So for example, this is x, so I divide them by x. So I can easily see that the x will be cancelled out. So that means A will be times with x plus 1 and 2x minus 1. Awak nak ambil dua-dua ni pun boleh, but for me it is a good practice to compare your denominator. And then for B, so we got x plus 1, 2x minus 1 over x plus 1. So bahagikan, kita akan nampak B will be multiplied with x, multiplied with 2x minus 1. And then plus with C. Okay, so for C, we got x plus 1 over 2x minus 1 divided by 2x minus 1. So cancel out. Kalau dah lama-lama tak perlu tulis macam ni pun okey. So C times with x, x plus 1. And then over your denominator x, x plus 1, 2x minus 1. So ini untuk kita samakan pembawah. So ini untuk step yang kedua lah. So this is the first step, you separate them into linear function. Second step, you are having a common denominator. So ini proses nak samakan pembawah. Once you have a common denominator, wala sama lah pula bahagian pembawah. So kita compare lah bahagian numerator. So take your numerator on the left hand side. Take the numerator on the right hand side. Therefore, 5x plus 1 is equal to A times with x plus 1, 2x minus 1, plus with B, x, 2x minus 1, plus with C, x, x plus 1. So this is the third step where we compare our numerator. Okay, so first step, separate them into different fraction. And then second step, having a common denominator. Third step, compare your numerator, compare bahagian atas. So now the fourth step. The fourth step, you can choose. Either you want to use substitution or you are going to use comparing coefficient. So substitution boleh, comparing coefficient boleh. Biasanya kalau untuk this thing saya kata pakai substitution cepat sikit. Cepat macam mana? Tengoklah nanti. Okay, so let's say you want to use substitution right. So for me, I say, if you look at your denominator, find out what are the zeros of your denominator. So in this case, the zeros are 0. 0 tu daripada sini lah, x equal to 0. Over here is negative 1. Over here, this is 1 over 2. So for me, I prefer to substitute with x equal to 0, x equal to negative 1, and x equal to half. Of course, kalau tak nak guna nombor-nombor ni pun boleh, pakai nombor lain pun okay. But normally, if you substitute with the zeros, biasanya antara A, B, C tu, dia yang lain tu dia akan jadi kosong. So kita akan dapat terus constant dia nilai berapa. So for example, if let's say you let x equal to 0, you substitute over here. So 5 times 0 plus with 1 equal to A, and then 0 plus 1, 1, 2 times 0, 0, 0 minus 1, negative 1. But over here, B will be times with 0, so dia akan jadi kosong. C will be times with 0, so it will become 0. Therefore, we can easily calculate what is the value of A. So A is actually equal to negative 1. And then of course, you can easily substitute with x equal to negative 1. So let x equal to negative 1. And then another one is let x equal to half. So nanti kalau ganti dengan half, yang ni akan dapat kosong. 2x minus 1 dapat kosong, depan pun dapat kosong. So boleh cari nilai C. Oh, Dira dah dapat dah. Oh, laju Dira. Ke Dira tengok jawapan Dira? Okay, so now jangan give up lah. Benda ni senang je. Dia kalau leceh sikit pun sebab dia kena kira je. Benda ni tak ada apa pun. Senang je. Don't worry. Be happy. Oh, Mr. Tang. Haha, tak pasal, sabar je lah. Okay, never mind. Let's check the answer then. So, saya delete yang ni dulu lah. Okay, so now we substitute with x equal to 0. We are going to get A equal to negative 1. And then when x is equal to negative 1, we are going to see that B is equal to negative 4 over 3. And then if you substitute with x equal to half, you are going to end up with C equal to 14 over 3. Therefore, your partial fraction, so it will become negative 1 over x, negative 4 over 3, x plus 1, positive 14/3 to x minus 1. So dapatlah partial fraction kita. What about the rest of you? Are you guys doing okay? Are you guys okay? Okay. Okay, Dira dapat, Khairina dapat, orang lain dapat. Tiba-tiba okay dah. Siapa Zaid Mukmin ni? Amirul Mukmin ke? Oh, kalau nampak saya sengit sikit sebab iPad saya kat sebelah. Oh, okay. Mana orang lain ni? Oh, Syahira pun okay. Siapa lah dia tadi? Oh, Pilapong. Pilapong okay. Okay sikit. Okay sikit ah. Pembisi ni. Tak baik Dira cakap macam tu. Pong tengah study tau. Sian dia, fokus study. Okay, so now let me proceed with the next one. Okay, so this is type 2 when we have a repeated factor. So for example, if let's say you have 6x squared minus 15x minus 8 over x minus 3, x plus 5 squared. So this is the repeated factor. So yang ni linear biasa, so x minus 3. Repeated factor, so we are going to do x plus 5, x plus 5 squared. If let's say this is cube, that means we have another one with x plus 5 cube. Kalau katakanlah kan dia x kuasa 4 kan. So dia akan ada something over x, something over x square, something over x cube, something over x to the power 4. So itu repeated lah. Okay, what else? And don't forget that everything must be constant sebab dia masih linear. Cumanya dia linear yang repeat saja. Okay, so now for example, x minus 1 over x squared times with 3x plus 5. So this is simply a linear factor, but these two are repeated. So x and then another one with x squared. So ini kita tak categorizekan dia sebagai kuadratik sebab dia adalah linear factor yang repeated. Kita boleh repeat dia 2 kali. Okay, so example 7. Express 7x over x plus 2 squared in partial fractions. So we give you a simple one first. Okay, so separate them. 7x over x plus 2 square, so it will become a over x plus 2 plus b over x plus 2 square. And then you need to have a common denominator. So this is the reason why I say it is a good practice to compare your denominator with the denominator on the left hand side. So for example, this one we got x plus 2 square. So the denominator on the left hand side, x plus 2 square. For the a, I simply have x plus 2. So when you cancel them out, you will be left with x plus 2. So this one will be times with a. Meanwhile, for the b, we have x plus 2 square over x plus 2 square. So when you divide them, you are going to get 1. So that means we simply times b with 1. Okay, so A multiply with x plus 2, B simply multiply with 1. Sebab bila kita bahagi tu, kita dapat nombor 1 kan. Okay, so now that is the second step. So now the third step, we are having the same denominator now. So do make sure to compare your numerator. So 7x is equal to A, x plus 2 plus B. So that is the third step. So first step, buka dulu. Second step, make sure you have a common denominator. Third step, you need to compare your numerator. And then for the fourth step, you can choose either to use substitution or you can use comparing coefficient, either one. Okay, so for this one, let us try to use comparing coefficient. So we expand them a little bit. So a times x is ax, a times 2 is 2a plus with b. And then by comparing coefficient, you can see that for the x, if we compare the left hand side and right hand side, a is equal to 7. And then if you compare for the constant, 2a plus b is equal to 0, which means that b must be equal to negative 2 times with a. So it will become negative 14. Therefore, our partial fraction is 7 over x plus 2 minus 14 over x plus 2 squared. So this one is by using comparing coefficient. Okay, so okay ah. Ke tak sempat nak salin? Sempat ke nak salin? Okay, so saya bagi 5 saat untuk snap kalau tak sempat. Ting, 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 ting. This one. Okay, so now done with this, let me proceed with the next one. Example 8. Express 1 over x square minus 1 in partial fractions. Okay, so whenever you have a quadratic function in your denominator, so if let's say we have a quadratic, we should check first, can we factorize them completely or not? So in this case, x square is actually a repeated linear, so that is okay. X square minus 1, so this is a quadratic, so we should check first, can we factorize them or not? Obviously, you can actually factorize them to become, so x square minus 1, this is actually x minus 1 together with x plus 1. So we are not having something with a quadratic, but this is actually a linear function. So two linear function actually. So we have repeated linear and another two linear. Okay, so therefore 1 over, so this is repeated linear. So a over x plus b over x square. And then x square minus 1, they will become x minus 1 and x plus 1. So we got a constant over x plus 1, a constant over x minus 1. So I already separate them for you. Now your job is to make sure you have a common denominator. And then once you have a common denominator, compare your numerator. And then you can either use substitution or comparing coefficient. So do make sure to find out the value of A, B, C and D. So again, I'll give you 5 minutes for you to solve them. Saya bagi masa lah. Sementara tu kalau ada part yang mana-mana yang tak faham, boleh tulis kat situ lah. So nanti saya tengok kejap part mana yang tak faham. Kalau ikut partial fraction dia tak susah, tapi dia kena banyak berhati-hati. Sebab kalau kata kita tersalah darab sikit, dia mungkin akan efek banyak benda lah. So algebra kena cekap sikit. Algebra nak cekap, for me there is only one way. Practice. Mesti kena practice banyak lah. So untuk siapa yang masih belum cekap dengan algebra, for me I'll say my advice lah. My advice for you to go through this again and do it on your own. So kena cuba buat sendiri, expand sendiri, darab sendiri, kira balik, compare balik apa yang betul, apa yang salah and etc. So biasanya untuk algebra, the only way for you to be more comfortable with the algebra is to practice a lot. Definitely need to practice. So dia tak ada shortcut lah untuk algebra. So ada certain orang dia rasa macam dia faham kan. Understand is one thing, but practice is another thing. Dia practice tu akan membuatkan kita lebih cekap. Kita faham, betul kita faham, tapi kita kena practice jugalah supaya kita lebih cekap. Oh, hari ni saya pakai internet. Harap laju sikit lah berbanding hari tu. So dah tukar tempat. Pergi tempat yang dekat dengan mendalah tu. Dah apa dah nama dia. Sama je lah. Ada siapa-siapa yang tak okey? Boleh tulis kat situ kalau tak okey kat mana-mana. Dahaga pula banyak sangat cakap ni. Confused tak? Mana budak-budak T5 lah? Asal macam tak nampak pun. Mana budak-budak T5? Cik kasih hi sikit. Tu T4, T3. T1, T2 pun tak nampak. T6, T7, T8. Di manakah kalian? Ya, Khairina. Kenapa? Sudah pening. Oh, ada Miss T1. Oh, T1 ada. Okay, T7. Ada orang tu kan, dia tak masuk kelas minggu, dia lupa dah ada kelas mana satu. Sabar je lah. Lagi Amir Mukmi tu kan, dia pun datang kan. Dia dah tak kenal dah Amir je siapa, sabar je lah. Oh, ada T5 ada, T1 ada. T2 tak ada. T3 tadi ada. T4, T5, T6. Tak nampak pun. T7, T8. Okay. No, ada dah T2. Okay, so now we want to have a common denominator first. So ini step yang pertama kan, kita pecahkan dia. Okay, so second step, we want to have a common denominator. So what do we do is that we're gonna take the denominator on the left hand side. So we have x square, and then we have x square minus 1, and then we divide them by x. Sebab dekat A ni ada x kan. So bila kita bahagi, kita akan tinggal x square minus 1. So that means A will be times with x and then x square minus 1 plus with B. So untuk B pula kita ada x square minus 1 over bawah B ada x square, so x square cancel out, so we are left with x square minus 1 plus with C. Okay, so x square x minus 1 x plus 1 and then divide them by x plus 1. Sebab bawah C tu x plus 1 kan. Okay, you divide them. So C x square and then x minus 1 plus D. Okay, so we have x square x plus 1 x minus 1 over below our denominator here is x minus 1. So cancel out. Oops, cancel out. So we have x square x plus 1 over x square minus 1. So this is 1 over x square minus 1. So that is how we have a common denominator. So do make sure to refer to the denominator on the left hand side, and your denominator you divide them, whatever left you times with your constant. So sebab tu daripada awal saya kata it's a good practice for you to check your denominator and the denominator on the left hand side. So simply divide them, whatever left you simply times with your numerator. Okay, so this is the second step where I having the same denominator. So now let us compare your numerator. So you can easily see 1 is equal to A x square minus 1 plus with B x square minus 1 plus with C x square x minus 1 plus with D x square x plus 1. Okay, so this is the third step where I compare the numerator. So done with the third step, the fourth step you can choose. Either you want to use comparing coefficient or you can choose to use substitution. Nak guna substitution boleh, nak use comparing coefficient boleh. Tapi untuk saya substitution lebih simple lah. Okay, so if I want to use substitution, I need to refer to my denominator and calculate its zeros. So I have x square minus 1. So the zeros for this is 0, 1 and negative 1. Tapi saya ada nilai A, B, C, D. So ini baru 3 nilai lah, 0, 1, negatif 1. So nanti kalau saya nak ganti, saya akan pilih lagi satu nombor lah. Mungkin 2 ke, 3 ke. Okay. So firstly, let me show you the working. So ni nak erase lah. So kita tunjuk yang pakai Microsoft Equation lah, dia cantik sikit. Tulisan saya kan tak cantik, payah sikit nak faham. So jap, saya tunjuk yang cantik sikit. Well, misal tulisan saya memanglah ke laut sikit. Okay, so now. So this is what we did previously. We are having the same denominator and we compare our numerator. Okay, so when x is equal to 1, so you simply substitute on the left hand side and right hand side. You can easily see that b is equal to half. And then you compare with another one, x equal to -1. And then you can see that 1 is equal to -2c. Therefore, c is equal to -half. You substitute with x equal to 0, it will give you the value of b, where b is equal to -1. So kita dah pakai semua zeros lah. 1 dah, -1 dah, 0 pun dah. So choose any other number because we need to calculate what is the value of a. So in this case, they simply substitute with x equal to 2. So they are going to get a polynomial. When they substitute the value of x equal to 2, it will get 6a plus 3b plus 4c plus 12d. And then you simply substitute the value of b, c and d because we want to calculate the value of a. And then you can easily see that the value of a is actually equal to 0. Therefore, since a is 0, so we don't have anything over x, so you simply start with b. So -1 over x squared. So this is b over x squared. And then plus with c over x plus 1 plus with d over x minus 1. Okay, so c over x plus 1, so -half x plus 1 plus half x minus 1. So that is the fraction. Are you guys doing good? So macam habis. Okay, bisa kot. Right, so tak apa. Right, so that means for the next class or the next lecture next week. So for next week, we are going to finish chapter 6. And then, so we are going to finish chapter 6 during the first hour. And the second hour, we are going to start with chapter 7, the new chapter, chapter 7. Okay, so next week, I think I'll see you guys in lecture, I think, in DKB 2, because everyone will be back, right? Except some of you who couldn't come back. So, later on, we'll do, nanti kita buat ni sikit lah, nanti awak tolong tulis lah siapa yang tak boleh balik tu. Sebab saya rasa siapa yang tak boleh balik tu lecture saya kena ajar kot guna Google Meet ke apa ke. So nanti update lah siapa yang tak boleh balik. Okay, so with that, I'll see you guys next week in lecture hall. Bye-bye everyone. Good night and goodbye. So I'll see you guys next week. Don't miss me too much. Bye.